Hello, dear students. Today we are going to proceed with chapter on genetics. Objective of our lesson will be the source of heredity. To know about the source of heredity, the structure of DNA. Third, it will be the structure of RNA. Then it will be DNA replication, followed by protein synthesis. Lastly, mutations. So DNA and the source of heredity. It was written that we wish to suggest a structure for the source of deoxyribonucleic acid. The structure has features which are of considerable scientific interest. It has not escaped to our notice that the specific base pairing inherent in the proposed structure suggests a possible copying mechanism for the genetic material. So these were written by these two persons, James Watson and Francis Crick, who were the first one to give the X-ray diffraction of the structure of DNA on the 25th April of 1953. Mr. Watson was a molecular biologist, and he was also the head of the Human Genome Project at the National Institute of Health in the UK. And Mr. Crick was a neuroscientist at that time, a physicist also, and he died in 2004. Both shared the Nobel Prize in 1962 for their discoveries on the structure of DNA. That is a handwritten sketch of the DNA made by Watson and Crick in those years. And if you go to the history of DNA, it was first discovered by Measure in 1869, 10 years before the original species proposed by Charles Darwin. And that's a picture of the Measure. And in 1944, before the structure of DNA was proposed, Avery demonstrated that DNA transferred genetic material, and Avery demonstrated by a series of experiments. From him, we know today that DNA contains all the genetic information that are needed for the making of protein, making of life. Some few things about the original species. A theory developed by Charles Darwin, a naturalist. It is based on the selection and evolution. There is no science of genetics at the time of Darwin in 1882. It's worth noting. He was a naturalist, so he was observing how evolution of the species happened in plants and animals at this time on that island. The structure of DNA now, DNA stands for deoxyribonucleic acid. It is a polymer. We use the term macromolecule when it is natural. It consists of nucleotide elements. And it is made by the condensation of nucleotides. A nucleotide consists of three parts: a sugar, which is given. It consists of also. Now, the difference between ribose and deoxyribose, as you can see, is there. So if you have ribose, then it is going to become ribonucleic acid, RNA. And if you use deoxyribose, then it's going to become DNA, deoxyribonucleic acid. It contains also a phosphate group. And there are 4 nitrogen bases that are nitrogen bases. They are adenine, thymine, and cytosine. Depending on the type of nucleotide, it will depending on the type of nucleotide you need, you have to choose between one of those 4. Thymine, they are also referred as the purines, while thymine and cytosine, they are referred as the pyrimidines, so they are grouped together. That is therefore a collection of those 3 things. First, the phosphate is going to react with the sugar, something known as phosphate and sugar linkage. This is known as an ester linkage, and then a base comes in. A nucleotide. So this is the structure of a nucleotide. The name of the bond is really represented this way. easy molecular optimization. And nucleotides are going to join with other nucleotides, and you can see the bond condensation that will happen to give a dinucleotide. The process will continue until you have, and if you take two strands of the polynucleotide held together by some bonding that is there between them, the hydrogen bond, you have the formation of the DNA. So in this way, you know how the DNA is made. The DNA.